Experimental and numerical evaluation of compression confinement techniques for high-strength concrete beams reinforced with different ratios of high-strength steel reinforcement. Methodology. Two different compression confinement techniques were studied experimentally and numerically. The first method is used high modulus carbon fiber reinforced polymers sheets around the compression zone. And the second method was using steel fibers reinforced concrete in the compression zone by 1% volume fraction. 12 specimens of high-strength concrete beams with 4 reinforcement ratios were prepared. The specimens were separated into 3 groups called control, CFRP, and SF technique. A 3D finite element analysis was done and validated with published experimental data. Results. Experimental and numerical results show that at raw minimum, the CFRP confinement technique enhances the ductility index more than steel fiber confinement technique. Also, at raw minimum, the CFRP confinement technique enhances the ductility index more than steel fiber confinement technique. While at raw average and raw maximum, the steel fiber confinement technique gives more ductility than CFRP technique. On the other hand, the used confinement techniques were improved the strength ratio at all steel reinforcement ratios, with obviously increasing in case of steel fiber. Conclusion. Based on the experimental and numerical results, the following conclusion can be drawn. First, for steel fiber reinforced confinement technique, the cracking load value was improved by about 108.4%. And the maximum load was improved by about 52.73% at minimum area of steel reinforcement. Second, the steel fiber strengthening techniques increases the ultimate load by about 48.7% at average area of steel reinforcement. Third, for maximum steel reinforcement ratios, using the steel fiber reinforced technique can increase the strength and ductility ratios by 8 and 118% respectively. Fourth, using carbon fiber reinforced polymers technique has a slight effect on the strength and ductility index. Also, for steel reinforcement ratios more than the maximum ratios, using the steel fiber reinforced technique can increase the strength and ductility ratios by 5% and 48% respectively. Finally, the numerical results showed the similar behaviors as found in experimental results, but the results value were not identical. Thank you.